Welcome. We use computers every day to manipulate data, but have you ever stopped to ask yourself how that data is stored? Hello, my name is Paul and this is Barebones Tech. Take a look at this. What is it? What if I were to ask you if this were an order? Pause the video and give this some thought, and when you're ready, keep watching. I think it's fair to say that most of you probably looked at the left of the screen and thought 46, and regarding the list, you most likely said yes. But is that the case? The problem here is that you're a human being with inherent intelligence. In reality, what you're seeing is a pattern of light and dark spots on the screen. You, however, inferred that this part represented the value 12, this part represented the value 34, and this symbol in the middle was an instruction to add those values together. Think of it this way: if instead of 1, 2 plus 3, 4, I'd put down AB plus CD, you may well have responded ABCD. But if that's the case, why isn't this 1, 2, 3, 4? Moving on to the list. Your human intelligence allowed you to infer that these symbols represented the values 1 to 20, and they are indeed in ascending numerical order. However, if you were to name a bunch of files on a computer, 1.doc, 2.doc, etc., then the computer would give them a very different order, since it would apply the sorting methodology more normally associated with text. You're probably thinking, so what? Which is completely reasonable. The what revolves around how computers see the world. In this example, you were seeing patterns of light and dark on a screen and inferring meaning. Instead of patterns of light and dark, modern digital computers work with patterns of ones and zeros. Whether these are stored in the computer's internal memory, written out to disk or other removable media, or transmitted over some form of network, ones and zeros are all the computer has to work with. Unfortunately, unlike you, the computer cannot directly infer anything from those patterns, and so it is up to us as programmers to instruct the computer on how to interpret them. That's what this series of videos is about. The smallest unit of storage for a computer is the binary digit, or bit. Being binary, it can be in one of two distinct states: on or off, yes or no, true or false, or more usually thought of as 1 or 0. A single bit is not very flexible. However, if we were to consider two of them together, we now have 4 possible combinations. Both are 0, the first is 0 and the second is 1, the first is 1 and the second is 0, or both are 1. Put 3 together and we now have 8 possibilities. And each time we add a bit, we double the number of combinations. 4 gives us 16, 5 32, and so on. By the time we get to 8 bits, we have 256 combinations available, which is much more useful than the 2 possibilities given by our single bit. Most of computing in the modern world deals with these groups of 8 bits, so we give these groupings a name. Sometimes they're referred to as octets, but we more commonly refer to them as a byte. If we need more combinations, then it is normal to work with multiple bytes, rather than looking at adding 1 or 2 more bits. If we put 2 bytes together, 16 bits, we get 65,536 combinations, and so on. The problem is, what does the pattern actually represent? Say we have 0100, 0001. Is this the number 41? Or the letter A? Or something else entirely? As we work through the upcoming videos, we will examine various answers to that very question. In the next video, I'll be going on to look at one of the most basic types of data a computer may be asked to work with, the integer. If you don't want to miss that, you know the drill. Please subscribe and ring the bell. While you're at it, likes are appreciated and comments welcome. Finally, share this video with other like-minded folks who you think will enjoy it. If you have any questions, or you'd like me to make a video diving into any of the background in more detail, the comments are there for your use. Once again, my name's Paul and this has been Barebones Tech. Until next time, thank you for watching.